All right, hello, hello. Welcome, welcome. This is the first and maybe only video going into two-step conversion web problems. It's the same basic idea as the one-step problems. It's just that you, well, have two steps. So yeah, let's get into this. It's not, like I said, not too much harder. So this question, we have 15 grams of sodium chloride. How many molecules of sodium chloride do I have? So what makes this different, we have 15 grams, that's a mass, and it's asking for how many molecules. That's items. So instead of making or jumping one of these arrows, we're jumping two of them. We have to go from mass to items. But you'll notice there is no arrow connecting these two. You can't go straight from mass to atoms. You have to go from mass to moles to items. Now, you could do this the way that we have been working, where you do a one-step problem to convert mass into moles, and then use another one-step problem to convert the moles into the number of molecules. But it's actually easier and faster and more accurate to do it in one big conversion table, which is the difference between a one-step problem and a two-step problem. In a two-step problem, we're going to use both the molar mass and Avogadro's number in the same table. So we'll actually do this whole conversion in one calculation. And that's what I'm going to show you how to do in this video. Okay, we'll do problem 15 first, and then 16 I'm going to have you guys take a crack at on your own, and I will put I might walk through it, maybe I'll just throw the answer up. I haven't decided yet. We'll see. But let's start with this one. First off, our known. Our known is 15 grams of sodium chloride. Now, sodium chloride is a name. We need a formula. Sodium is Na, Cl -1. Both have a charge of 1. Sodium is positive 1, chlorine is negative 1. So this is just NaCl. So we have 15.00 grams NaCl. And that is our known. Actually, don't need to get up there, do I? Reach that right there. And now we are at mass trying to get to moles. So we need the molar mass. So we're going to have to calculate the molar mass for this. So for molar mass, we have 1 Na and 1 Cl. So NaCl. Na is 22.9898. Chlorine is 35 something, 35.453. Since there's only one of each, we can just add those two numbers up. That's going to be an 8, 2, 4, another 4, 8, 5. And then, since this number has 5 digits and this number has 6, we need to round this in our 5th digit, which means that is going to be a 3. And in hindsight, I should probably pause this and check that on a calculator, because I obviously am human and I make mistakes. So I'll be right back. All right, good news. I can math. All right, so let's put this up here. So we have our molar mass of 58.443. This is a molar mass, so we're going to use the first thing on the back of the periodic table, which is going to be grams. Formula is NaCl, and that is all over 1 mole of NaCl. So we're in grams already, so we have to invert this when we put it down. So the 58 has to go on the bottom, and the 1 mole goes on the top. So our mass, grams of NaCl, now cancels, which leaves us with moles of NaCl. But that annoying question I kept asking in the last couple of videos, is this what we want? The answer is finally no. We don't want moles. Moles is not what we're after. We want molecules. We need to now get here. This, if we solve it right now, is going to give us moles. We can tell that because that's the unit that's left. But we don't want moles, we want items. So we're going to go on now. We've made it here. Now we need to cross the second arrow to get to items, which means now we need to use Avogadro's number. Now Avogadro's number, we don't have to do a calculation for it. We just know it. We just have to put the right units on. So I didn't put my brackets on this, which figures because this is the first time I actually need them. So now Avogadro's number is 6.022 E23. That's going to be molecules because this is a compound, and that is NaCl all over 1 mole of NaCl. So now this fraction has to go into the table as well, just like this one did. So again, we have to look at our units. We are currently in moles of NaCl, which means we need moles in the bottom. So this fraction, unlike this one, this is going to go in right side up. We don't have to flip this one. So we can just copy that over. 6.022 E20, that's a 6. I want 23. Molecules NaCl per 1 mole NaCl. And now the moles of NaCl cancel, and that leaves us with molecules of NaCl, which is what we actually want from this problem. So now we are ready to actually solve this. So we put equals, and this time we're actually going to have a number on both the top and the bottom. On a two-step problem, you're pretty much guaranteed that you're going to have a numerator and a denominator and have to actually do the calculation there. Now, the denominator is still not terribly difficult because it is just one thing that isn't a 1. But the top, we got to do that. So 15.00 times 6.022 second E23 gives us 9.033 E24. And now to check our digits, we have 4 and 4. So we can leave this as it is because we got a 4-digit number. Now we need to actually divide those two. Oh, and I almost forgot the units. Molecules of NaCl. Don't want to lose those. It's very easy to lose those in this problem. Don't forget, you need to keep track of those. So now we take this number and divide it by that one. So divided by 58.443, which leaves us 1.546, nope, 5456, 08542, E23, and I'm going to move down to the bottom for the units, molecules, NaCl. And of course, we have to do our sig figs on this. So if we have 4 digits in this number and 5 digits in that number, we can only have 4 in our final answer. So the 4th digit is this 5, which means that this 6 following it, that it is also going to have to change. Cross out the rest of that. That becomes a 6, which makes our final answer 1.54 6 E23 molecules of NaCl. So I'll step back so you can see that whole thing. And remind you that we are building up to 3-step problems. So space is going to eventually start to become an issue. So working on your handwriting might be important on these. So now I'm going to erase this calculation and put question 16 up. I have 24.73 times 10 to the 23rd iron atoms. How many grams of iron do I have? So I want you guys to pause this and work this one out. Okay, take a crack at this problem on your own. So pause it, come back once you've got an attempt, and we'll go through it and see how you did. Okay, so for this problem, we are instead going the opposite direction. So this time we're starting with items, which actually means this table is probably going to take up a little less space. We're starting with items and trying to get to mass. So this time we are going to start with Avogadro's number and then use the molar mass. Other than that, it's the same process we used up here. We're just going in the opposite direction. So this time our known is the number of iron atoms we have. So 24.73 times 10 to the third Fe. I did that backwards. Atoms. Fe. And that is the end of our known. So the first thing we're going to use is Avogadro's number. So that's going to be 6.022 times 10 to the 23rd. Atoms this time, because iron is an atom, not a compound, unless it's bonded to something, of Fe, all over 1 mole of Fe. We need atoms to cancel, so atoms in this one has to go in the denominator. So this time Avogadro's number is going to be upside down. So 6.022 times 10 to the 23rd atoms of Fe per 1 mole of Fe. So then our atoms cancel, not the E23, start with the atoms to cancel, which puts us now in moles of Fe, but as said last time, moles of Fe is not actually what we want. We want grams. So now we need our molar mass. Now, this time, the molar mass is easy because it's an element. It's not a compound. So it's just whatever it is on the periodic table. So our molar mass is going to be 55.845 grams of Fe per 1 mole of Fe. Moles needs to cancel, so this goes in right side up. 55 on top and the 1 on the bottom. Moles of Fe cancel, leaving us with grams of Fe, which is what we actually want. So from here, we can start to solve this. So denominator, again, very straightforward. It's just the 6.022E23. Numerator, we have to actually math that one. So we have 24.73 3 times 10 to the 23rd times 55.845, which gives us a numerator of 1.38104,685 E26 grams of Fe. Sig figs, we have hit equals on the calculator. We have a 6-digit and a 4-digit, so this needs to be rounded at 4. So the 1 is the last sig fig, so all the rest of this goes away. Nope, not all of it. Hang on. I wiped out too much. The E26 needs to stay. Be very careful you don't do that. It's very easy to do. I've done it multiple times. It will throw off your answer. Okay, so we have 1.381 E26 over 6.022 E23, which will go back into the calculator. 1.381 second E26 divided by 6.022 second E23. That's not right. Hang on. I got 200,000. That's not right. Missed a decimal point. There we go. Okay, 230. That sounds a little more reasonable. 229.3258054 grams of Fe. Again, sig figs, we have 4 digits and 4 digits, so we want 4 digits. This time there is no exponent written here. There's no E20 anything. So I can just drop the rest of the numbers, which makes my final answer 229.3 grams of iron. And that is where I'm going to end this video. My class is going over this today. We're going to start this here in about an hour and a half. I guess more like 2 hours. We're going to go through this in class. So I might do more of these. I don't think I'm going to need to do more than 2 though. At this point, the next step would be to start working on worksheet 4.2, which is, of course, not posted yet. I need to finish updating it. It's going to be shorter than worksheet 4.1 is because it's the same idea. It's just a little bit longer of a problem. Once we've expanded the conversion web to a full web, then we'll start doing some of the larger worksheets again. So that's where I'm going to end this video. Have a wonderful day, and we'll see how well this does. Maybe I'll need to do a second video. I don't know. Have a good one.